Hello again. Welcome to chapter 5, where we shall deal with pointer types. In order to understand some basic questions concerning pointers, let us approach this particular chapter by our mode of questions and answers. What are the pointer types? Pointer types refer to variables that store addresses of computer memory or addresses of RAM instead of storing data such as numbers, characters, or strings. Now, how are pointer types declared? Pointers are declared by the aid of an indirection operator, which is this symbol that is a star. So you will declare an integer by using the keyword int. Now, after typing the character, which would be the identifier, you will have to associate it with this particular symbol, which presides that particular character or identifier. How are the addresses stored in the variable? Addresses are assigned to variables through address operator, which is this symbol ampersand. Now, in order to understand this particular issue, let us look at this line here. This is include whatever. This is include int main is starting here, curly bracket opening, but here we are declaring variable y. This is a normal variable, integer type we have declared, but then x, which is presided by this particular symbol star, is a variable of type integer, but it will not store a number or characters. It will store the address memory, like the address of y. So when we enter data here in y, we can enter 20 in y, but then the address of variable y, which was declared here, can be entered into x. And for that matter, we can access data into y, so y. But yet, because the address of y has been stored in x, we can access data into y using x and the indirection operator. In order to understand this particular phenomenon, let us go and see what happens in actual implementation. Here we have a program. These are libraries, int main, starting from here, ending at this particular line. Then here is where variables are declared. These are two variables of integer type. We already know how these variables function. But this line here, int star a star b, is where we are declaring pointers. Two pointer variables have been declared. One is called a and another is b, and they will store addresses of memory just as they can store addresses of p and address of w or any other integer variable, as we shall see. At this line, we have entered two integers. This message will appear on the screen. So here, we will enter data into w, and here we will enter data into p. However, here you can see the address of variable w is being assigned in a, and here the address of variable p is being assigned in b. That means these pointers now are receiving addresses of variables. Now, since they are receiving addresses of variables, it means we can access those variables through these pointers. So here now we are saying w and p, the values of w and p from w and p. That is C out w, C out p. If we have entered 10 here and 20 here, with this particular line we will see 10, and this particular line we will see 20. However, here we are accessing w and p from a and b. So here when we say C out star a and C out star b, we are going to see the same values which were entered into w and p. Let us run this program and see how it operates. So we compile. After compilation, let us run. Enter two integers. We enter 56, we enter 76. Now, what we are seeing, W and P from W and P. This is C out W, this C out P, we are getting it. But this W and P from A and B, this is C out star A and this is C out star B. We are seeing the same values using different identifiers. That one shows how we can access variables through pointers. Now, in order to understand this particular phenomena more clearly, let us resort to our visualization, and using RAM diagrams, we will try and see how data are entered in these particular variables. So before int WP, we have this following situation. Before int WP, this is empty, empty, after empty. After declaration, this is what we are going to see. This is after declaration. After declaration, we have W, we have P, reserved, reserved, and we have A and B reserved. No big difference. This is free. Now, after C in W, C in P, after entering data, after this line and this line, and even after this line and this line, the memory will change. This is after entry of data and assignment. So here is the situation. This one, variables were declared. Now we have this situation. Now assume that before variable declaration, this is memory location 01, and this is memory location 02, this is memory location 03, this is memory location 04, and this is 05, and this is 06. This is how memory is addressed in computer due to the function of operating system. So now, after declaration, we know now that W is in address 01, P is in address 02, A is in address 03, and B is in address 04. So this one doesn't change 01, this doesn't change 02, this is 03, and this is 04, 04, and this is W, this is P, this is A, and this is A, and this is B. The rest is 05, 06, 07, but these are empty. They are not occupied. However, they have their addresses. So after declaration and after this reservation, on C in W and P, if I enter 10 here and I enter 20 here, that is as far as these two lines here are concerned. Now what happens here? Let us see what happens here. On A, assign the ampersand W, actually A will receive 01, will receive 01, which is this address here. And when we see B is assigned ampersand P, then because P is at 02, this will receive 02. So now, as you can see clearly, let us see how the situation looks in a much more better drawing. If we extrapolate this particular drawing here, this is 01, this is 02, this is 02, sorry, let me just rub this one here so that we can see. So this is 01, this is 02, this is 03, this is 04, this is 05, 05, 06. But now this is W, this is P, this is A, and this is B. Now in W there is 10. In P there is 20. In A there is 01, that is this address here. And in B, 01, sorry, 01. And in B there is 02, which is this address here of P. Now these are due to line number 2, execution of line number 12 and line number 13. So this is the status of RAM up to this particular juncture here. So when we come to output, C out W, then we are going to see 10 from here. C out P, we are going to see 20 from there. But when we see now C out star A, actually it is, we want to see what is in where A is pointing. Now A is pointing to this particular address, which is 10. So we are going to see 10. And when we see C out star B, since B is pointing at 02 and at 02 there is 20, we are going to see 20 coming from that particular variable. So this is just the way addresses can be captured and how they can be used to manipulate data or even get output from the computer. This is the basic example of how we can use these particular facilities in programming. You will learn better how to use most of these when we start to implement data structures when we come to data structures and algorithms. For now, let me thank you and say bye-bye.